So another way to look at this data for honey as a cough suppressant here is to construct a histogram for the data. And a histogram is either a frequency or a relative frequency bar graph. So your horizontal axis is going to be the variable, and then the vertical axis is going to be frequency or relative frequency. The class intervals are the non-overlapping categories for your variable. And just as a general guideline, if you have less than 25 observations, you generally want to have about 5 to 6 classes if you're choosing the groupings. 25 to 50 observations, 7 to 14 classes, and more than 50 observations, 15 to 20 classes. Now, in relation to those classes, the class width, you take the high minus the low value of all the data and divide it by how many classes you want. So in our case, the high was 15 and the low is 1. And I want 15 classes. So if I do that, I divide that out, I get 0.93. Because I've got a lot of data here. I've got greater than 50 data values. So I'm going to do 15 classes. So that gives 0.93, which will round up to the next whole number 1. So we'll just do classes of 1. So now what I've got here is the class, and then the frequency, and then the relative frequency. So my classes are just all the 1s, all the 2s, 3s, 4s, etc., all the way up to 15. So for frequency, I'm looking at the frequency of 1s. This is the overall data, so this is all of the data. So I go back up to my data here, and I count how many 1s I've got in my table there. And I count a total of 3 1s. So you've got a 1 here, and you've got 1 here, and you've got 1 here. So, and those are all of the 1s in the data. So we've got 3 values of 1. So that first frequency is going to be 3. And then we go up and count how many times does 2 occur in the data. And actually there are no 2s in that data. And then we keep going and so on. So there were 3 3s, 3 4s, 4 5s, 9 6s, all the way down to 1 15. So this is a total of 64 values, 64 data values, 64 observations. So to figure my relative frequency, I'll take my frequency and divide by 64. So 3 divided by 64, 0 divided by 64, 3 divided by 64, etc. So 3 divided by 64 rounds to 0.05, 0 divided by 64, 0, and so on, all the way down. And then these should sum up to approximately 1.00 or 100%. So now I've got a couple of this frequency. This is the frequency distribution and then the relative frequency distribution. So the distribution is the chart. And then when we graph those, these graphs are histograms. So the graph of the frequency distribution or relative frequency distribution. So along the horizontal, I've got my improvement score. Along the vertical, I've got frequency. So we had no zeros, but we had 3 1s. So this is a bar of height 3 that's at 1. No 2s, so there's no bar there. 3s and 4s had frequency 3. So 3s and 4s here up to height 3. 5s, there was 4 5s. So on 5, we're up here to height 4, and so on for the rest of the data. So these are the frequencies of all of the data values. And then this is the same thing, except we're looking at the relative frequency. So instead of graphing these values, which are graphed here, we graph the proportions here. So notice that these two graphs have the same shape. They both have sort of 2 areas of concentration here, and they're not symmetric. Certainly not bell-shaped. But then we can do center, outlier, symmetry, and spread for this data as well. So we could do center, outlier, symmetry, and spread. So the center of the data, I would gauge the center of the data, about right here, approximately 9. Outliers, well, we have a gap here, so possible outliers at 1. So put a question mark there. 1, the 3 ones are possible outliers. Symmetry, it's not a symmetric. Distribution. And then the spread, we can tell that this data is fairly spread out with, it has 2 areas of concentration here, but quite spread out from 1 to 15. So it's not all concentrated in just 2 numbers. Like when we did the stem and leaf here, all concentrated in the 0s and the 10s. So that's much more concentrated area in that display. So that's frequency histogram and relative frequency histogram. Sometimes we want to group the data. So when we group it, we can have a grouped frequency distribution or a grouped relative frequency distribution. That's the chart. So here I grouped scores of 1 to 2, 3 to 4, 5 to 6, 7 to 8, 9 to 10, 11 to 12, 13, 14, 15, 16. So I count up all the 1s and 2s, there were 3 of them, all the 3s and 4s, there were 6 of them, and so on. Still a total of 64 here. So then to get these relative frequencies, that first one, I did the frequency 3 divided by the total of 64, and did that all the way down. So then in my grouped data, I can have a grouped frequency distribution here, and then grouped relative frequency. So notice it kind of smooths things out a little bit. We don't have the gaps anymore. We are still kind of seeing that same general shape here that's not symmetric. But we can analyze with SAUCE if we want to. Center, outlier, symmetry, spread, just like we did before. Notice here when we group, though, that we lose our individual measurements. We can't recover those individual measurements from either the grouped frequency or grouped relative frequency. But it does smooth out some of the distribution. So you can also, if you enter the data in your calculator, you can also graph a histogram on your TI-84, and those steps are listed here. I won't go through those steps in this example because most of the time we won't be graphing these on the calculator. We'll be using software to do that.